All right, and with that, I'm excited to introduce Mr. Greg Holzrichter. He's the CMO at Big Switch Networks. Thanks for being on, Greg.
Glad to be here, David.
Go ahead, take it away. Tell us about Big Switch Networks.
Fantastic. Well, yes, I'd like to introduce Big Switch Networks. We are a next-generation data center networking company based in Silicon Valley. I'm going to introduce the background of the company, go over a little bit of our technology stack, and talk specifically about a next-generation monitoring fabric, which is an alternative to a Bigamon, NetScout, or Ixia, and also a next-generation data center switching fabric, which is an alternative to Cisco ACI in particular, although we get compared sometimes to Arista CloudVision as well. And the genesis of the company actually comes from Stanford University back in 2010, one of the early groups that was exploring sort of academic SDN. And the three teams that came out of that group, principally looking at alternatives to this concept of traditional switch-by-switch management, which has led networking to have a very brittle, very slow-to-change architecture that really hasn't changed much over the last 20 years and is very CLI-based. And so the researchers at Stanford were looking at a different way to manage networks. Three groups actually came out of that. One went over and went over to build the Google network. The second was a group that formed the startup Nicira that VMware ended up acquiring in 2012 for about $1.2 billion. And the third was Big Switch. And so Big Switch has been a pioneer in SDN since then. But at the time of 2012, when VMware acquired Nicira, the company had to make an important decision, which was, do we want to continue to compete with NSX forevermore, or do we re-architect the solution to, instead of become a SDN overlay similar to a Nuage or an NSX or a PlumGrid? We went out to the market and looked in 2012 at what some of the more innovative players were doing in terms of doing networking in a fundamentally different way. And so we spoke with some of those groups that went over to Google, some of the teams that went over to Facebook, and we're solving this problem of network manageability in a completely different way, given that they were trying to solve for hyperscale challenges, which not every enterprise has. But what we were able to do is take those concepts of core and pod design, of SDN control, and hardware independence based on either white box switches or what Gartner calls branded white box or bright box with either Dell Open Networking or now HPE Altaline, and deliver that type of efficiency through packaged software on to any organization, and to deliver this significantly more efficient way of doing networking. And so really what we were able to do is we have this software layer that sits on top of your industry standard switches and becomes the easy button of management to make changes, to be very programmatic, and to really enable this concept of getting towards autonomous networking, or as many people are starting to talk about these days, intent-based networking. So this concept of being able to manage your network and do multiple different steps in order to design what in fact you want your network to do, to then deploy that and then implement using multiple different CLI-based config steps. And this tends to be very slow. And so instead, what we've come up with, and we've worked with third-party research groups, one in particular called ACG Research, that did a time and motion study on how long it takes to get a regular traditional networking pod up and running versus this next generation approach, where basically you turn on an SDN controller, it discovers your leaf and spine switches and automatically deploys a very thin networking OS, which then reports back to the SDN controller and brings up the fabric. And so that 12 to 15 times faster than all of the kind of monotonous steps on traditional network deployment. And really, it's the underpinning of a simplicity and abstraction of your layer 2, layer 3 physical network that is presented up through a single API into OpenStack through very high performance, highly scalable Neutron plugins, or through vCenter APIs to be able to actually show up as a tab in the vCenter and make it very easy for the vAdmin to instantiate a VM, provision that VM, and then push that live all in one work stream, or integrate into some of these emerging container orchestrators, whether that's Kubernetes or Mesosphere or Docker Swarm. And so this concept of delivering on intent-based networking and delivering agility and automation is really the design point for the Big Switch stack. But when you look at what traditional networking is composed of, on the left I'm showing a traditional chassis pair, Cat 6K. It's composed of the supervisor card connected to the line card through a fabric backplane. And so the innovation that Big Switch has brought to the market is taking those proven networking concepts, but deploying them on scale-out industry-standard hardware. So instead of a supervisor card, you actually have an x86-based SDN controller that actually, in our smaller deployments, can be a VM controller. You have a concept of a two-tier leaf spine architecture. And so our spine switches are high density. Leaf switches are top of rack industry standard switches. And this can scale out to 128 leaf switches managed by a single SDN controller. It's a redundant SDN controller, so no single point of failure. And if for some reason both controllers were to go down, it continues to forward packets in headless mode. So we've done some pretty extensive chaos monkey tests and have published a variety of these proof points on what happens when you actually start randomly unplugging ports, turning off switches, killing the SDN controller, and there's zero application impact. The benefit of this type of approach is that it really is the easy button of management. So instead of hunting down which port has gone down or which switch in the data center row is not performing, looking at each individual switch via a CLI, with the Big Switch approach, you have Big Switch software that's sitting as a networking OS on your leaf and spine components, all managed through a single SDN controller. And this manages all of your layer 2, layer 3 physical network as if it was one big switch, and that's the name of the company. But when you are able to do that, you change fundamentally the way that you're able to manage your physical network. And this is how Google and Facebook have achieved significant improvement. So, one network admin at Facebook manages literally thousands of switches versus in many organizations and enterprises, that ratio is more like one net admin to 50 or 100. So you're able to scale dramatically, and you get this concept of much easier, agile deployment. We've developed these SDN-based solutions, and now we've actually built this out in use cases. So one product of ours is called Big Cloud Fabric. It's a next-generation data center switching solution, and we've optimized it to be deployed specifically in your VMware SDDC. I mentioned the ACI or the Cisco ACI alternative, but in the VMware use case, we're plugging in through the vCenter API. We are able to interact with NSX, and I'll talk a little bit more in detail. You can think of which is the ideal SDN underlay for an NSX deployment. And we're also delivering networking simplicity to hyper-converged deployments. So solutions like vSAN in the VMware family or Nutanix and others, as you get larger in terms of scale out in the number of nodes in your hyper-converged deployment, you start to get networking complexity, and we manage all of that automatically. So it really is an ideal solution for that HCI deployment model. We also have a very scalable OpenStack deployment. Verizon is a very large customer of ours. They were looking for their next-gen NFV deployment architecture 2 years ago, looked at 19 different networking solutions, and ended up deploying a Red Hat OpenStack orchestrator with Big Cloud Fabric on Dell as the basis for their next-gen NFV architecture, and they've now scaled this out over 6 regional data centers and over 200 racks of deployment. And multiple other carriers have kind of picked this idea up and are rolling with it. And more recently, we're seeing a lot more interest in container networking, and I'll talk more about that. But as more organizations are deploying containers in production and seeing what happens when you have lots and lots of ephemeral containers that live and get decommissioned very quickly, having a networking fabric that automatically provisions, automatically prunes, delivers these networking resources in these very dynamic environments, this is a ideal architecture that allows you to deliver on that promise. But we also have a really interesting insertion point where many of our customers start to deploy, and that's in the data center monitoring, the network monitoring solution, where you may have your Cisco production network, but you want better visibility. And so today you may have a Gigamon or an Ixia or a NetScout, premium price network packet broker solutions. And what we found is that we're able to actually deploy in a very interesting differentiated way using the SDN controller and industry standard top of rack switches for half the cost. It allows you to get pervasive visibility. So you really can afford to tap every rack and see all of that east-west traffic. We also have a very interesting use case in the DMZ security, so software-based service chaining that I'll talk a little bit more about it as well. And all of this really was architected, inspired by these hyperscale concepts, packaged in enterprise software that you can deploy on your choice of industry standard hardware. One of the things that we're proud about is that Gartner has looked at, industry trends in data center networking, and both Cumulus and Big Switch are the only startups that were positioned in the visionary quadrant this year in the Magic Quadrant. And a lot of that was based on these concepts of, the CLI is dead, the API is cool, the ability of, using fabrics as the new normal, and really talking about open standards. And so, we'll be sending a link out to allow you to download this Magic Quadrant report, and I encourage you to take a look at, the comparing and contrasting some of the different traditional approaches to networking and what sort of innovative startups are doing as an alternative. When you look at how we're deploying, graphically in the data center, there's three key areas where we add value and deploy. So if you look from left to right, you have packets that are coming in from the untrusted zone. And what we found is a very interesting way of deploying layer 4 through 7 services through appliances that you already have. So you've made your purchase in your SSL decrypt or your firewall or your intrusion detection. But most organizations in the DMZ today have your security ops team and your net ops team work together. You have all packets traversing every single one of those appliances. And, you scale up and pay more licenses as your volume increases. It's, a daisy chain of services. It tends to be quite brittle. Making changes and upgrades impacts all the other services in the chain. So you have, limited maintenance windows to make changes. And so what we found is that you can actually plug those layer 4 through 7 services as appliances directly into our SDN controller. And then we act as a bump in the wire where we can route different packets based on different flows and policies. And so in a drag and drop, very easy to manage interface, you can say, all right, all of these packets coming from these whitelisted IP addresses only have to traverse these 3 services. These other suspect packets, they'll traverse all 5 of these services and get quarantined. And you can, therefore reduce the number of packets hitting every single one of your appliances. You can save money on tooling, and, basically this type of solution pays for itself. A lot of organizations are looking at this as a pretty interesting, different approach to thinking about DMZ security. With that same SDN controller, we actually can also work in an out-of-band monitoring mode. And so in this case, through a tap or a span port, we can take copies of your packets from whatever your traditional production network is today, and in a much more cost-effective manner, take copies of those packets. You don't have to be selective in terms of sampling and which packets you're taking from your production network. You can take them all because we're half the cost of traditional network packet brokers. And as a result, you can see all the packets traversing east-west in highly virtualized environments. 80% of your traffic is east-west, and hand that off to your centralized tooling. And again, we can be intelligent in terms of how we're deploying because we have the SDN controller, the top-of-rack industry standard switches. And then what's quite innovative, in order to get these higher-level network packet broker functions, we have an Intel-based DPDK service node that does some of these higher-level functions like header stripping, deduplication, pattern matching, and time stamping and the like, before it hands those off to the specific tools. And again, you have that intelligence because you've aggregated all of these packets to only send the right packets to the right tools, again, thus saving tool license dollars. So a lot of organizations begin their SDN journey with this out-of-band monitoring. When we were first starting out in the market back in 2014, it was deemed to be less risky. Our first customer was a design win, and we built this actually for Microsoft, and we've since deployed this now across very large service providers, government entities, enterprises, and it's been a fantastic insertion strategy where our partners over at Dell and now HPE and EdgeCore resell this software. They provide end-to-end support, and they're able to offer this as an alternative solution that does things in a much more agile way. And then finally, what we're seeing on the right-hand side is this data center. Sorry, I switched that around. The data center switching fabric is the middle section. The data center monitoring is over to the right, where I just explained the aggregation and handing it over to your centralized tooling. The central area is the data center switching, and again, this is you can start small with a unique single rack of workload. We've seen customers start with a VDI deployment or big data at the side of your existing production network, and then expand the footprint. And so this concept of not disruptive, not rip and replace. You can start small, get experience using the solution, and then roll that out. So as I mentioned, we have 4 different use cases, and we've been working a lot to actually plumb into these orchestrators that sit above us to be able to abstract out all of the layer 2, layer 3 physical components of your network and present it up as one entity, making it much easier to manage. And this kind of integration and automation, I think, is one of the key differentiation points that we have. We have, very intuitive UI, but we also have an API-first philosophy where we inform both our CLI, if that's what your team is most comfortable using, but also a very powerful built-in analytics and drillable dashboards that allow you to see exactly what's going on, visualizing, each element in your network, literally down to the point where there's connection points where you can see cables, are ports green, do you have connectivity, and it makes troubleshooting literally 12 to 15 times faster according to ACG research. So if you look at the VMware use cases, if you're going down the path of vSphere or NSX or vSAN, these are workloads that all require physical networks. And so what we are able to deliver is this concept of automation and automatic connectivity to the fabric, VM level and container level visibility, as well as end-to-end troubleshooting with a very intuitive path concept that we have. And so in the case of NSX, this is one of these interesting things where Big Switch 1.0 was considered a competitor to NSX. As we re-architected and came out the other side, we are now this ideal SDN underlay that is ideally suited for NSX. And in fact, NSX BU has invited and partnered with Big Switch, and we are delivering end-to-end VTEP integration. So you have both troubleshooting on the virtual switch side as well as the physical L2, L3. And so you have this concept of end-to-end VTEP to VTEP troubleshooting that allows you to reverse the host to leaf to spine to leaf and back down to the host. Also viewing each element down to the VM level. And so instead of deploying on a Cisco ACI or an Arista, this allows you to dramatically reduce that physical networking cost and leaves additional dollars left over for deployments of your VMware environments. And you get that automation benefit across the virtual as well as the physical network to boot. We're also seeing quite a bit of interest in container networking. I went to the OpenStack event earlier this year, as well as DockerCon, and we'll be going to KubeCon later on this year in Austin. And the number of conversations that we've had, even in the hallways of VMworld this year, around container networking was actually quite exciting. And I think that it really is an indicator of the rapid adoption of containers. But the historical precedent that we kind of are finding now is it reminds us a little bit of OpenStack 3 or 4 years back, when people didn't realize how many bumps and bruises and sharp edges there might be on that OpenStack journey, especially around Neutron. And what we're finding is that when you look at the market for robust, scalable, kind of production-ready networking solutions for containers, they're few and far between. And so what we're showing in this particular case is this concept of how Big Switch is a SDN controller, which is the blue square in the middle, your spine switches and leaf switches with the blue component there, which is our software. But in the KVM environment and in containers, we actually have a small amount of software that runs on your server as well, as a CNI libnetwork-based plugin, so an OVS namespace to be specific. And so we're actually server resident, and as a result are very ideally suited to be able to instantiate and give resources at a per container level. And so your container orchestrator of choice is up above in this diagram. We're doing a lot of work with Red Hat, both on the OpenStack side, as I mentioned, very large deployment and reference architecture of Verizon, but increasingly a lot more work around Red Hat OpenShift, as well as Nozos and Kubernetes. We have an interesting customer, a large Chinese electric vehicle manufacturer, who has an innovation lab, a small data center here in Silicon Valley. And they looked at a variety of different solutions and ended up deploying Kubernetes in production with Big Cloud Fabric in order to get that automation and instantiation and pruning once they, culled the containers that they no longer needed. That went very well, and they ended up bringing us over to Shanghai for their production data center. And so again and again, we're having more and more conversations around container-based deployments. And as more organizations move from test and dev and want to actually get to scale with containers, the complexity around networking can be solved with this automated fabric type solution. And I think that the key reasons that once people hear about this new approach to networking, they look and see, hey, have other people gone before? And we've been able to amass more than 200 customers now who have deployed in multiple different regions, strong partnerships with big name brands that you know and trust, like Dell EMC and HPE. And it's really based around intelligence, this concept of converting from logical to physical. It's software that's allowing you to define your intent, and built-in visibility and analytics that really is unique in solutions that are packaged today. Agility also is one of the elements that people are looking for. Although in the poll that David just flagged on this particular end, it looks like performance is one of the number one elements that folks are looking for. And we have a non-blocking, very scalable architecture that can be deployed anywhere from 1 gig up to 100 gig in terms of the underlying hardware. And it gives you that flexibility of hardware, whether that's white box, and we have large government enterprise as well as service providers going down that white box route, or with branded white box on Dell or HPE. And this concept of being agile and allowing you to work with multiple orchestrators and a single physical infrastructure. And so what I mean by that is that you can actually have vSphere 6.5. You can have multiple different types, or versions of vSphere. You can have NSX. You can have a small pod of, containers and test and dev, as well as OpenStack, all managed on the single underlying hardware, but managed through that SDN controller tying into those different types of orchestrators. It gives you immense flexibility in terms of, which workloads you want to deploy and how you want to deploy it. And, further to that, just this concept of, who has gone before. And, we have a really interesting voice of the customer platform that we've deployed and done a fair amount of customer survey work where we're getting, real world feedback. And so I encourage you to go to Gartner.com, and they have a whole site called Peer Insights, where 15 different customers have shared their experience of what it's like working with this new approach to both monitoring as well as security and data center switching. And multiple examples of NSX deployments on Big Switch and White Box, data center transformation and digital transformation with a interesting use case with Dubai Municipality, who was doing a data center refresh and consolidation based on vSphere, but on top of Big Cloud Fabric, and able to, the networking team was given 30 days to cut over, and they called us after one day, and they were up and running. And the technology was not the issue. It was getting a couple of approvals to push things live. So, kind of order of magnitude in efficiencies and how you're managing networking. A regional credit union that actually has deployed vSAN on Big Switch and seen that kind of agility and simplicity of networking that completes the picture of hyperconverged. It's not just compute and storage. It actually, is the third leg of that stool to make you have this mini SDVC deployment that has the automation and networking agility that I think is the promise of HCI, as well as kind of significant deployments in service providers like Verizon and others, and some pretty interesting use cases that I alluded to around Kubernetes in production. And so solution that is based in software that is intuitive for the teams to get up and running quickly, and the ability to really see this concept of the easy button of networking and giving you choice in terms of approaches on how you want to deploy, whether that's hardware or the type of orchestrator that you'd like to use. And really this is what's fueling our over 100% year-over-year growth and geographic expansion. And so, with that, I invite you to actually go to our Big Switch Labs, which is labs.bigswitch.com. Over 6,000 people have actually gone here. It's a you point your browser, sign in, and you get your own Revelo instance. There's 12 different modules. You can actually, self-paced labs. You can take a look at our monitoring, how we integrate with OpenStack, how we support containers. A really very easy to manage and quite interesting environment where you can actually get up and running in minutes without having to ship hardware around. If you do want to take this first spin in your own lab, we do also have a free community edition that's on the website that I encourage you to also take a look at as well. So with that, I will pass it back to David.
Great presentation, Greg. I was just making a note here to try out the Big Switch Community Edition. I need to try that out myself. So we do have quite a few questions here for you from the audience. If you haven't asked a question yet out there, now's the time to do it. So, Greg, the first question I wanted to ask you is, is software-defined networking, from Big Switch, is this just for large enterprises, or can it help SMBs as well?
Yeah, it actually is very scalable. So you can start with, a single switch or a single rack and work your way up. And I think one of the exciting things that we see often is that many of the SMB organizations we talk to can't afford the traditional network packet brokers. The price per port is just too off-putting. And so, when you can actually put in an industry standard top-of-rack switch and, a VM controller, the price to get started and start monitoring what's going on in your production network, even if that's, one rack, is definitely accessible. And yet we've also seen, very large organizations like Fidelity roll that out to, 140 racks. Large, intelligence community deployments, as well as service providers. So it's a software solution that scales, but it delivers that order of magnitude or improvement in operational experience in networking, the reduction in complexity, from teams that are very small all the way up to large ones. And one of the things that we found interesting in VMware deployments in particular, especially as you get to these smaller accounts or blended groups that have multiple responsibilities, we were just at the VMworld show and talked with a lot of the admins who really don't speak networking. And so what this does is it allows better communication between your networking specialists and your server and storage teams. We call it networking at the speed of virtualization. And what we mean by that is, a vAdmin, instantiates a VM in vCenter, provisions your software-defined storage, and then often you have to file a NetOps ticket and wait hours or days for the networking team to push that VM live. It's, fairly, undifferentiated work, and most CTAs we talk to, want to be doing higher level other, types of tasks in the data center. So with Big Switch, because of our plugin to vCenter, the vAdmin can actually, instantiate, provision, but then push that VM into a predefined sandbox, or in this case, your production network, all in one workflow. And so it really increases the agility in VMware environments, and whether that's an SMB or larger.
Excellent. Yeah, that's good to know. And another question I had for you here is, say I'm a virtualization admin, I'm interested in putting in VMware NSX. Why is it that I need an underlay? How does that help me? Why is that important?
Yeah, well, so NSX manages the virtual switch in VMware environments and provides both automation as well as microsegmentation for security, which is one of the big areas of focus that VMware and the NSX team deliver differentiation on. But you need to have a physical network for that NSX to actually get deployed. So, many people may start with a traditional network that you already have, but one of the challenges is that, you don't have, not all networking platforms have been invited into the NSX partnership program where you're able to do VTEP integration. And why is VTEP integration important? Well, one of the challenges of troubleshooting in an NSX environment is that if you don't have end-to-end visibility and some type of performance degradation occurs, is there a problem with your virtual switch, or is it a problem with your physical L2, L3 network? And so, having that ability to deploy, NSX on top of Big Cloud Fabric on Dell, for example, you have this nice end-to-end stack that is automated. You have end-to-end visibility in addition to the features and benefits of NSX. And the traditional, or rather the Big Switch plus Dell, or Big Switch plus Edge Core, or Big Switch plus HPE Alto line, the CapEx to secure that network is significantly less than if you were to go down the traditional Cisco path, for example. And so you, again, are compressing the CapEx at acquisition. And then, and I was just at an interesting conference last week where, for every dollar of CapEx, it's estimated that there are $3 or $4 of OpEx managing a network. So if you can actually reduce the CapEx, that's great. but reducing the OpEx has an even bigger benefit, and that's exactly the benefit that we help deliver.
Excellent, excellent. And for the easiest place to get started with Big Switch Networks, is that, I know you mentioned the labs, and then you have a community edition. Is that true?
We do, yeah. I think that those are two of the easiest places to get started. And again, that's labs.bigswitch.com. And very easy to point your browser there. And the benefit is that you get to actually see the UI and step through on a self-paced basis. Community edition, we often see as a second step where people have taken some modules and want to try this out in your own environment. We do have a hardware compatibility list, so if you sign up for Community Edition, we'll let you know the makes and models of those EdgeCore, Dell, and HPE switches to procure. But then we also have a very robust webinar program and a monthly newsletter. And so I encourage you to go to bigswitch.com, and the resources tab has quite a number of recorded webinars on a variety of different partnerships. We've done webinars from with VMware, with Red Hat, as well as 30 different tooling partners for our monitoring solution, where we have some really interesting integrations with SSL decryption, tying in with Bluecoat/Symantec, FireEye, as well as a variety of other layer 4 through 7 services. So, really, delivering those packets to the right tools in a very, kind of efficient tool farm approach, even opening up pretty interesting monitoring opportunities for, remote branch offices where you can, have one of our top-of-rack switches that backhauls that traffic to your central tool farm and allows you to deliver analytics that you may, and tooling that you may not want to deploy or can't afford to deploy at a bunch of your branch locations, but you can actually bring that back to a centralized tool farm. And that's a use case that we see deployed quite a bit with this out-of-band monitoring solution.
Excellent, excellent. Well, I think that's all the time we have for live questions. But thanks so much for being on the event today, Greg.
Thanks a lot, David. Appreciate it.